So we see that we have two different isotopes here of uranium, and what varies here is their number of neutrons. And so if we see that most isotopes which occur are stable, but a few of them we can make unstable by, you know, adding neutrons to them. Unstable isotopes want to become stable. They do that by releasing energy, and this process is called a radioactive decay. Okay, so what do we mean by radioactivity again? Radioactive decay is a process in which an unstable atomic nucleus loses energy by emitting radiation in the form of particles or electromagnetic waves. So either we're going to be getting a beta particle, an alpha particle, or a gamma radiation, which is the electromagnetic wave. And again, it is doing this so that it can become more stable. Now, here is the nuclear stability belt. This is a plot of all the different particles. And these guys that are near this line are all stable, but as you get further away, here are all your unstable guys. And these guys are going to want to fall down and come down over here by producing smaller particles. Okay. Now, again, here are those things being mentioned again. An alpha particle, which we basically is going to see what it is. It's just basically like the nucleus of a helium atom. It's just two protons and two neutrons. So mass of 4, and it's a positively charged particle, and it's relatively massive compared to this guy, which is just an electron, a fast-moving electron. So imagine a heavy-moving particle here, a light-moving faster particle there, and a really penetrating radiation over here. That's your gamma, beta, and alpha. These are the guys, the earlier pioneers of radioactivity, important names to know. The Curie, especially Marie Curie here, one of the few women that were really famous in science back then. Here's an alpha particle, again, 2 protons, 2 neutrons. Okay, it's just like a helium nucleus. Here's alpha decay happening. This atom is going to lose 4 of its neutrons and protons, or 2 neutrons and 2 protons. Its atomic number reduces by 2, and so this and this are produced, this particle, which is going to be this -4 and that -2, plus the alpha particle. Now, you guys don't really need to know this, but I'm going to kind of just go over it to make sure that you guys kind of see what really happens. So here we have a particle here that is 226 and 88. So it has that many protons and neutrons, and that's the atomic number. It's undergoing a alpha decay, and so we're going to have radium becoming into radon and helium. Now, here we go. We see that this gets reduced by 4, that got reduced by 2, but if you add this up, this plus this is always going to equal this. So the total particles are conserved. And this is also going to be the sum of this and this. So you add these two guys, the products should equal to whatever it started up with. And so everything is conserved here. And this number is going to be the sum of those two. So that's the whole process. It's pretty simple. And we can write it down like this, that this particle started up, and now it became into this plus this. So if you just know that the helium is always going to be a 4/2, the alpha particle is always going to be that. So this is always going to be that minus that's going to be that, and that minus that is going to be that. So we could always kind of figure out if there's any blanks to fill up, what they should be, because these should always balance out. Okay, some more examples for you to look at. Same thing happening. Some element here is becoming into thorium and helium. Well, what do you think that element must be? Well, these two must add up to 234. These two must add up to 92. Well, 234 over 92, look at the periodic table, and you know, hey, that must have been uranium. And so that's how you can figure out what X was, or the unknown particle. Okay, same thing, the X could be over here. You could see what's going to be formed there. So, for example, that's what they did over here. This became into something plus that. Well, what is that something? That something is going to be this -4, this -2, because those have to balance out. And so you look that up, and that would be polonium. Okay, you guys don't need to learn